completely trivial unless there's something in front of them, like a negative or a number, unless there's something that could change the stuff on the inside. But is there? Or is there a power on the outside of the parentheses? No. So what I'm trying to say here is it looks nice and hard, but guess what? You've done this before. I can drop those parentheses, can't I? They were serving me zero purpose. Now be careful. I can only drop them. Would you let me? Let's see. I can only drop them because that right there is a positive. Remember, if I had a number there or even a negative, there would be an extra step. You got to be careful for that. But since it's just plus and there's nothing in front of my parentheses, I can drop them and just write all the pieces. The only tricky part here is me reminding you of something. So here, let me tell you this first. If I have something, note, if I have x squared plus x squared, do I multiply those powers? Oh, I don't multiply. I don't even add them, do I? That's what I meant to say. Nothing special with the powers. Huh. Special stuff with exponents, with the powers, was only for what? Multiplying and dividing, right? And to be more specific, it was when I had, remember I kept preaching and getting on my soapbox last time saying, hey guys, notice, multiplication is everywhere. There's no pluses or minuses. Notice it's multiply and divide. No pluses or minuses. Plus and minus changes everything. It goes back to being more simple, actually. You don't have as much power anymore. You can't put your stuff just together unless it matches perfectly. When it matches perfectly, we call this what kind of a term? When two terms match, so you can add the coefficients, the numbers in front. X squared and x squared over here in this note on the right. They're called like terms, aren't they? And in front, there's actually an invisible 1. So my answer is 2x squared. Remember? That's how we handle stuff when we have plus or minus. We go back to the basic, add your regular numbers, add your like terms, add your matching stuff, but nothing complicated. This is what you wish you were doing all semester. Just regular adding. Seriously, that's all this is. Let's see, I have a 3 squared in front, 3x squared. Do I have anything else with a like term? Any other x's with a 2 on it? Okay, so I'm going to get 4 plus 3 is, you're right, not well in the truth. Okay, 7x squared. Do I have any other x's? Wait, I don't. Okay, so I'll just write that one. Do I have any other regular numbers? -7 and -3 gives me 7, 8, 9, 10, 11, -11. And then I have an x cubed. Any other x cubes? Okay, so positive 7x cubed. I don't know. Yeah, I think so. I think you're right. I think the 7 and a 3 is a 10. In fact, I know it. I was just being funny. That's a good point. So this right here is the right answer. But earlier tonight we talked about the fact that we do like to write them in descending order. We don't have to, but we can. Let's go ahead and practice that, just in case the author wants us to. So to practice that, what's the biggest power? Which one can I put in front? So I'll put or, because I wouldn't count this against you. 7x cubed. Let's put the squared next. Plus, since that's the next power down. Then what? Plus 2x minus 10. Notice how it gets messy right there. Kel, that's how yours was, because you get in the center of the screen when you wrote it on the board earlier. It just starts messing up. Both are the same. I don't care which one you use. The back of the book will probably write it like that. Nice. So it's like you're just matching blocks and adding them together. Okay. That's nothing hard. The only hard thing is if you try to cross what you did last night. That's when it becomes hard. So be careful not to mix up 6.1 with 6.2. They're completely different. Adding and subtracting is actually easier. Yeah. A minus? Absolutely. Let's look at one with a minus, yeah. Because we know that when you have a minus or a number in front of parentheses, we do something called distribution, right? But that's so significant, it's going to change everything. In this section, they're not even going to test us by putting that number in front. They'll just put a negative. So let me show you what that might look like. Let's say you had how about, I'm going to modify one slightly that I see in the book. For example, I'm going to say you have x, oh yeah, I got to use parentheses, of course, minus 3x, just because they do. I should follow along the way the author does things. I am going to change something, so if you notice this in your homework, note to self, it's a different problem. Okay, I'm subtracting polynomials. Merry Christmas. Wait a second, okay. So the first thing I want to do is get rid of the parentheses. That's what order of operations tells me, isn't it? Can I drop the parentheses, or is there something in front that's bugging me? There's definitely something in front. And you know what? It's so tempting to just cancel out those x's that are almost touching. Can I do that, though? Or is that minus the entire piece? Yeah, it's minus the entire piece. It's not just minus the 2 in front. It's minus all of it. So I'm going to have to actually get rid of those parentheses the old-fashioned way by distributing, by sharing this with every piece in parentheses. So a negative and a negative gives me what kind of 2x squared? Okay. A negative and a negative, I get another positive, and then a negative. So share it with every piece. And remember, negatives just negate. It just changes the sign of everything inside. Done. That's it. Sure. Was that Taylor who said that? Who said that? Taylor? Good point. Now you can drop the parentheses on the other one too. And that's nice because now we just start combining similar blocks, similar terms. Where did the minus go? Nope. You only show us what it's in front of. Because that's what it's stuck onto. Yeah. That minus is only in front of the stuff on the right. Now that we have this, we'll look at like terms. X squared plus 2x squared. So 2 plus 1, what do I get? 3x squared, perfect. 3x, do I have any other plain x's? Wait a second, negative 3 and the positive 3? Oh, I'll get 0. They cancel, good. 8 minus 7, positive 1? Okay. Is that, it's okay that my answer is so much smaller than my original stuff? Sure. Absolutely. That, by the way, is called what kind of a polynomial specifically? A binomial. Okay. Good. And I'll tell you that the degree is 2. How many curves does it have? 1. Okay. These are actually our favorites. Soon, we're going to learn about something called quadratic, and that's this. Stuff that is special because it has a power of 2 with that one curve. We'll play with factoring and stuff later. Usually just trinomials in this class, but later on in life you'll learn about how to factor lots of stuff. Let me show you one more way that they can try to trick you, but it's almost a waste of time. I'm going to do it just because I don't want you guys getting mad at me. You know how I hate your wrath. Okay. I amuse myself. Okay. Okay. So subtract the 2. That's basically what we just looked at, right? Where you have 2 things being subtracted. You guys see that, but you see how they're trying to trick you? Let's do it together. Don't be freaking out about the fact that these are messy. Let's just focus on what the problem's asking, then we'll pay attention to the details. So, P of X. That's this stuff right here, isn't it? Right? So let's write it. Okay? P of X. I'll even put it in parentheses like the author would be happy if I did. Okay? Do I have a plus or a minus next? minus. And then for r of x, I better use parentheses on this side if nowhere else because I'm saying minus the whole piece. So these are the important parentheses. That's a 7, I think. Not too bad, I think. I mean, it's ugly, but let's deal with it. I'll give you a second to write. Let me circle this to the floor number. Okay, so the first thing I'm going to do is share this negative. I'm going to try to get rid of my parentheses. Yes, guys, it is absolutely true that those ends are driving me crazy too. But just like in those exponent problems we did last section, we don't stress out over that. We just do what we know how to do. We know how to get rid of that negative. So we try to ignore the end since we don't have a way to get rid of it. Does that make sense? So I've got, let's see, that's going to change my 5x to the 2n to a negative, right? Then we have plus 7. Oh, wait. That changed that to actually a negative, didn't it? Negative 7x to n, negative 1. It changes the sign of everything inside. Yeah. Ask.
Up there on that one, that's why am I not doing?
Because we did kind of, we just didn't show it. I could put a plus there if I wanted. It's because all I'm writing, hold on, let me highlight while I'm talking. All I've written here is what is this first term. And see how this one just changed to a negative? I didn't write the minus on purpose. It just happens that that's a negative number. Up here, I was still just writing this thing, but it changed it to a positive. Good question. Good question about the negative sign and why it stayed here, or at least it appears to, and in the other one it appears to go to a positive. And it's because really when we distributed, that first term was just being changed, and it was a coincidence that one became positive and the other negative. And it's completely okay. We don't keep the original negative. Okay, but what we do now is just combine like terms. So let's see, x to the 2n. Do I have any other x to the 2n's? Wait a second. It has to match exactly. We have to match the 2n power exactly, just like if it were a regular 2, right? Even though it's bugging us, we treat it like it's a normal squared, basically. Well, that has an n up there. Negative 5 and a positive 2, what do I get? Okay, you got it. So it doesn't change. Just like before, how the powers don't change or anything when you're adding and subtracting, same thing here. Do I have any other x to the n? So that's a plain one. Okay, so the negative 1x to the n, the negative 7x to the n. What is negative 7 minus 1? Negative 8? Okay. Let's put our numbers together. I got carried away that time. That's a negative 2. Okay, that's it. Even though it looked that tough, the ends just stayed there. Nothing ever even happened to them. Now remember, we did have problems with ends in them back in 6.1. But when you're multiplying, you treat everything so differently. When you're multiplying and dividing, you combine by adding, subtracting those powers, remember? With this stuff, no way. This is way easier. Just be careful with that negative if you have one. That's it. You guys learned a ton tonight. Thanks for your patience. And you only got